Hello, I'm Jonghyun Park, a master's degree student in computer engineering from Chungnam National University. Today, I will talk about how to improving crawler's performance that correct Tor hidden service. The presentation will proceed as follows. First is introduction and a problem challenge. Next is system architecture, and I will show hidden service contents and dynamics. Finally, I will finish the presentation with conclusion. Before we start, let me introduce Tor and hidden service. Tor is a special network that supports anonymous communication using onion routing. Tor is called a darknet, is a type of deep web. Tor's anonymous web service is called hidden service. They use a special address called onion address rather than an IP address or domain name. There are many illegal contents such as hacking, black market, and child pornography that exploit the anonymity of hidden service. There are some difficulties in crawling Tor's hidden service. First, Tor's slow access speed. Hidden service has 2.3 times slower page loading time than Surface Web. Even Surface Web using Tor 3.8 times slower. Second, hidden service is operated in a short term. Hidden services are often irregularly and often change their onion address. 40% of hidden service could not be accessed for more than 10 days in 150 days. Third, the number of unique onion addresses increase. Tor is increasing in number of users and service. This means need to crawling more hidden service pages. Our program is reduce crawling time by improving Tor hidden service crawler performance. We use the following method for problem solving. One is parallelize hidden service crawling through cloud instance, container-based virtualization, multiple browsers using tabs in the Tor browser, and clustering duplicated hidden service to minimize duplicate page crawling. This picture shows the overall structure of our system. The system consists of 4 main modules. Each module works by sharing Tor data such as onion address and hidden service pages. Then I will explain each module in detail. First, Tor onion address collector. Tor onion address collector collects onion address from the Surface Web. Some hidden service use a service called Tor2 Web to be accessible from the Surface Web. The hidden service using Tor2 Web use a special top-level domain for the onion address and is searched by the search engine. With this, our system searches special top-level domain from search engine and correct onion addresses. The original onion address is obtained by restoring the special top level domain from the collected onion addresses. The special top level domains of Tor2Web are listed in the table. These were collected manually from the Tor community or link directory. The figure shows the operation of the Docker-based Tor crawler. First, Docker Manager creates containers. Each container runs Tor browser with Selenium. At the same time, Tor is executed and the Tor request module and the onion address queue are prepared. The request module sends HTTP request to the hidden service. When an HTTP response arrives, it checks the status code and adds an accessible onion address to the queue. When the queue is full, open the tab and connect to all onion addresses. Attempt to connect to a hidden service and save the HTML of the open page. The corrected pages are stored in Tor data storage. The results of the following experiment show that using a Docker-based Tor crawler can reduce crawling time. We compare the crawling time for 100 sample onion addresses. We were able to shorten the crawling time from 38 minutes to 9 minutes. Using one browser, crawling time was shortened from 50% in 2 containers, 17% in 3, to 79% in 5 containers. But reduced time reduction rate from more than 4 containers. The reason for this is that many containers share resources such as CPU, RAM, and bandwidth in one instance. So we need to adjust the number of containers by instance spec. The following is the structure of Tor hidden service analyzer. This module consists of page similarity analyzer and onion address extractor. It updates the onion address set for the next query. Some hidden services use more than one onion address. In Tor's slow access speed environment, duplicated page collection is a big waste. Page similarity analyzer clusters duplicated hidden service to collect only representative onion addresses. The analyzer uses a cosine similarity calculation module to find duplicated hidden service page. Convert the text of two hidden service page into a word vector to calculate the similarity. It also used the HTTP response header comparison module. If both hidden services use the same server, it is assumed to return the same response header. This module complements low cosine similarity due to multilingual service and product price difference. The clustering results were as follows. We set the threshold for cosine similarity to 80% and the threshold for HTTP response header to 19%. 21% of the onion addresses were clustered from 2527 to 2014. Crawling time also reduced by 39% from 713 minutes to 433 minutes. Onion address extractor. Find new onion address. HTML link passing module. Find new onion address from the collected hidden service page. The onion address consists of 18 random alphanumeric characters. Therefore, HTML link passing module can use the regular expression on the slide. Use the regular expression on the slide to find the onion address. Cloud Manager controls the number of instances and containers, manages the execution of instance through the Cloud Instance Launcher. The Cloud Configuration module calculates the maximum number of instances and number of containers. The calculation considers the total onion address, the crawling time per address, and the instance spec. The onion address distribution module divides the total set of onion address and distributes them to each instance and container. Finally, we check the contents and dynamics of the hidden service. From January to May 2018, we collected 25,261 unique onion address and 2,527 unique hidden service. We manually categorize the contents for 722 hidden service. Illegal hidden service includes all categories except legal hidden service and unknown, such as adult porno, black market. They account for 42% of the total, which means that illegal services are running as much as legal hidden service. Legal hidden service include marketplace, personal blog, and server hosting service. In order to analyze the dynamics of hidden service, we counted the accessible dates from January to May and drew CDFs. 52% of hidden service are lower than the typical web's lifetime of 100 days. Only 7% were hidden service that can always be accessed, and 32 provides long-term service over 145 days. 7% of hidden service were short-term service running under 7 days. Our study is summarized as follows. We were able to shorten the crawling time by up to 79% through the Docker-based tool crawler. Clustering onion address for duplicated hidden service reduced 21% of total onion address and reduced crawling time by 39%. As a result of the analysis of the hidden service, they have a different environment from the normal web. There are various illegal hidden services in Tor, and it is difficult to access at all times due to irregular operation. I have finished my presentation now. Thank you.